In this video, I'm going to talk about spanning tree, root bridge, and port election process. I listed the process, as you can see here in this side, on this side of the screen. So select, I'm just gonna read the process, the main process. So select the root bridge. That is the number one step. Number two is select the root port, and third is select the designated port, and all non-root port and non-designated ports will be blocking ports. So that is basically the spanning tree, root bridge, and port election process. Also, I listed the Stp tiebreakers here. So number one is lowest root bridge ID, lowest root path cost to root bridge, lowest sender bridge ID, and lowest sender port ID. And I also listed some of the new Stp costs. So 10 gig has a link that is 10 gig has a cost of 2. 1 gig has a cost of 4. 100 Mbps link has a cost of 19, and 10 Mbps link has a cost of 100. So let's take a look at this diagram here. So as you can see, we've got 4 switches: switch 1, switch 2, switch 3, switch 4, and I listed the bridge ID of each switch. Of course, bridge ID consists of the priority and the MAC address, and if the priority is the same, the MAC address is the tiebreaker as listed here. So let's check the configuration of, or let's look at the spanning tree, root bridge, and port election process. So out of all the four switches, we have to select the root bridge that has the lowest bridge ID. So switch 1 has the bridge ID of this, switch 2 has the bridge ID of this, switch 3 has the bridge ID of this, and switch 4 has the bridge ID of this. So if you select the switch that has the lowest bridge ID, that would be switch 1, by looking at the bridge priority, which is the first section of the number here. So bridge priority in this case is 24577. So this is the lowest port priority, so, or the lowest bridge ID. So let's check if this is really the root bridge. So we can just do a spanning tree command. So in this case, I've got one VLAN, which is VLAN 1, and IEEE is, this switch is using IEEE spanning tree, as you can see here. This is probably PVST plus. So as I said, like I said, this is the switch that is the root bridge because it has the bridge. It has the lowest bridge ID. So as you can see here, this bridge is the root, and it's got the correct, the priority ID, which is this, and the MAC address is this. And if you are wondering how you can check out the bridge or the switch MAC address, you can actually do a show version and look for this section here, base Ethernet MAC address. So this is the MAC address of the switch. As you can see there, they are the same, just they have this different formatting. So we have selected the root bridge, and that is the number one step. Number two is select the root port per non-root bridge facing the root bridge based on the lowest cost. So let's check that. So select the root port per non-root bridge facing the root bridge based on the lowest cost. So let's check. Let's take a look at switch 2. Switch 2 has 2 links to get to the root bridge. So we can use our Stp tiebreakers here. So we can't use number 1 because we only have one bridge ID. Root bridge ID. We only have one root, and we can't use root path cost because our cost to get to the root bridge is the same. We can't use sender bridge ID because we only have one sender bridge ID. But we can use the lowest sender port ID, which is this is going to be our tiebreaker in this case. So lowest sender port ID. So the port ID of the sender So in this case, the root bridge. So let's check check switch 2 first. Show spanning screen. So it's using gig 1/0/4 as the root bridge. It's because of the sender port ID. So let's check the root bridge. Show span and tree. So out of 2 ports, gig 1/0/4 has the lowest port ID, and port ID, by the way, is composed of the port priority. This is the port priority here, and the port number or interface number is 4. So that is just the port number, as you can see here. So it's going to use this port because it has the lower port ID. So let's label this port. This is our root port. So every non-root bridge has a root port going to the root bridge. So port. So we have one root port on this switch to get to the root bridge. Let's take a look switch 3. So we can select this port because it has the lowest. So it has the lowest cost as stated here. So we can't use this link here because its link is more than the cost of this link, which is just 4. So as you can see here, 1 gig has a cost of 4, so it's going to be 4, 4, 4. So it's going to be 12 costs if you use cost if we use this link to get to the root bridge. So it's better to use this link, which is just directly connected to the root bridge. So let's verify if this is really the root port. Show span tree. So yeah, it is the root port, as you can see here. Let's label that port, root port. And now let's take a look at switch 4. Switch 4. Switch 4. So we can't use the cost because it has the same cost to get to the root bridge. But we can use the sender bridge ID, which is the number 3 out of STP, out of the Stp Tiebreakers. So bridge ID. So which one has the sender bridge ID? Is it switch 2 or switch 3? Let's take a look at the bridge ID. So in this case, switch 2 has the lower bridge ID. So switch 4 is going to use this link here, which is gig 1/0/1 as the root port. So let's verify that. Tree. So yeah, it is the root port, as you can see here. So let's label that port. Oops, sorry about that. My battery is running out. So that is our root port on switch 4, which is non-root bridge to get to the root bridge. So let's move on. So we have selected our root ports on our non-root bridges. So number 3 is select the designated port per segment based on the lowest cost to get to the root bridge. So basically, the segment that we are talking about here is the link between two switches. So this is one segment, this is one segment, this is one segment, this is one segment, this is one segment. So let's take a look switch 1, which is our root bridge. So generally the root bridge, all the ports on the root bridge are gonna be designated ports. So let's label the port here. Designated port. Designated port. Designated port. So we have a designated port on this segment. We have a designated port on this segment. We have a designated port on this segment. So let's check this segment. So in this case, the this is gonna be our designated port because it has the lowest. This link here has the lowest cost to get to the root port. I mean root bridge. So it's just, this is gonna be our root port. We can't use this because it is already a designated port. It is already a root port to get to the root bridge. So this is the last link that we check. So here to get to the root bridge, we can use this. We should use this link because it has the lower cost to get to the root bridge. So this is gonna be our designated port, and we can't use this because it has a higher cost to get to the root bridge, which is gonna be 8 cost. So this one has only a cost of 4. So this is gonna be our designated port. So we haven't verified this. So let's verify it. So as I said, like I said, all the ports on the root bridge are designated ports, as you can see here. And switch to its gig 1 slash 0 slash 1 is the designated port, which is correct. And switch 3, it's gig 1 slash 0 slash 4 is the designated port, which is correct. Let me say that again. Gig 1 slash 0 slash 4 is the designated port, as you can see here. And last is all non-root port and non-designated ports will be blocking ports. So this is gonna be a blocking port because this is neither designated port or a root port, and this is gonna be, and this port here is gonna be blocking port also. So let's make sure that all the ports are labeled. So designated port, root port, blocking port, designated port, root port, blocking port. So let's verify the blocking ports. So blocking port is the gigs 1 slash 0 slash 4, as you can see here, or alternate port. And let's go to switch 4. So gig 1 slash 0 slash 4 is the blocking port or the alternate port. So yeah, that's how you select the root bridge, and that's how port election process works. So I'm actually gonna put alternate. What's the alternate port? Alternate port. Alternate port. Is it? Yeah, alternate port. alternate port, alternate port, alternate port. So yeah, that's how spanning tree. That's how you select the root bridge, and that's how you select the root ports, designated ports, and the blocking ports. Yep, that's all in this video. Thanks for watching. Bye.